So we're also going to get into some story problems or some pictures, something like this, making you use some deductive reasoning. So this Yola person just planted a hybrid elm tree. Okay, so the nursery says the tree grows 12 feet per year. She wants to verify that. So she walks 100 feet from the base of the tree, and using a transit, it's basically just a little stand that you'd put a scope on. So the transit's 2 feet off the ground, angle of elevation is 5.7 to the top of the tree. So a year later, she does that exact same thing, and the angle of elevation is now 11.9. Okay, so we want to see if the nursery's claim is true. So we're going to need a picture here. There's our tree. Okay, she walked 100 yards away, and this little transit thing is 2 feet off the ground like this. So we have two different marks here. So we got one for year one that took us to, I don't know, here. We got another one for year two that took us to the top of the tree. So we get a picture like this, and also let's put one straight across here because we'll have to count for that 2 feet of height later. So from here to here is 2 feet, okay? This is the original height of the tree. Let's just call that Y1. This is the growth from year one. Okay, let's just call that Y2 right there. So we're basically trying to find if this Y2 right here grew 12 feet. So my first angle of elevation was 5.7 down here. The next one was 11.9. Okay, so I'm going to take one triangle here. I'm going to say tangent of 5.7, opposite is Y1 over the 100, because we stepped back 100 feet to do this. Okay, so the first little triangle right there. Okay, 9.98. So try not to round too much when you're doing these problems. So that's 9.98, plus we get that original 2. So this tree right now is 11.98 when she planted it. Okay, because we had to go up 2 feet here for the transit, just to account for that guy. Okay, so the next one now is going to be tangent of 11.9 equals opposite. Now we want to make sure we do a Y1 plus a Y2, okay? Because we're not just doing a triangle with this little piece right here. That's not a right triangle anymore, okay? That's a triangle of this. Sure, we could find this little guy here, but that's not a 90, so we don't have any way to do that. Okay, so make sure you're using this big triangle here if you're going to use the 11.9. Okay, and this is all over 100. But if we do that Y1 there, we can go do a substitution and put this in as 9.98. So when we go to solve this guy, we're now going to take tangent of 11.9, multiply that guy by 100, subtract off the 9.98, okay? And this little piece right here is 11.09. So, nursery's claim is false. They say it grew 12, it only grew 11. Not terribly wrong, but they're still liars. Last thing here is just kind of getting you guys used to this idea of complementary angles with the trig functions. So you've done tons of complementary stuff in geometry, okay? But we're actually going to do them with our trig functions now. So I want to know the sine of 60 where it's equal to cosine of something, okay? So I'm just going to tell you this is 30. Now some of you guys may be able to get that. If not, let's look why. So if I make this a 60, that means this is a 30, so 1, 2, square root of 3. Sine of 60, square root of 3 over 2. That is the exact same thing as going to 30 and doing adjacent over opposite. Okay? So if I ask for the cosine of 42, it's going to be the exact same thing as the sine of 48. Because 42, 48 get us to 90. Complementary means they add to 90. Okay? Tangent of 40 is going to be the exact same thing as the cotangent of 50. So if you want to see why that's true, we can use our calculator. We're still in degrees. Tangent of 40, okay, 0.83. So we can do 1 divided by tangent of 50 to represent a cotangent. And there you go. We can say cosine 42, same thing as a sine 48, and they match up. Okay, so you can use your calculator to help you out with these guys. So secant of 12 should be the exact same thing as a cosecant of 78 degrees. And you can check those in your calculator as well. Okay, so we'll get right to it, doing some problems here tomorrow, and also start in on our project for this quarter. See you guys tomorrow.